Next problem is also very nice one, and this problem was asked into your net December exam. Net December, that is 2019. Okay, this was again a very nice problem, and this problem has not any calculation, but in the examination, if you overthink about the problem, then you will do some wrong calculation. So you have to just, I have deliberately taken this problem because lot of people, when this question come into your exam, then lot of people have done blunder. Look at which type of blunder is there. And this is just all about the how you are writing this question, how you are reading this question. And after reading, you will just do some bad assumption and you will do wrong calculation. So what is this particular problem? This problem is that your psi x is given a L plus x, and that will be L minus x. And this is for the particle in box for x is between minus L to plus L. So this is, and this is basically wave function if x is between minus L to plus L and 0 otherwise. 0 otherwise. So this is your wave function particle in for the infinite box, and the box is defined between minus L to plus L. And what they just ask what will be probability such that your particle will in a state pi square h cut square upon 2m L square. Okay, so this was the question. They have just asked what will be probability that particle will be in this particular state. Most of the people do this question in a very hurry, and they just try to do this integration. They just use this particular thing pi square h cut square upon 2ml square, and they just use this integration that okay 0 to a, and they just take phi 1 star psi dx, and you can also go for, let's say, psi star psi dx, and you will take the mod psi square. Most of the people done this blunder, and fortunately one answer will also match with this particular answer. What is wrong here?
Sir, 5 is from minus L.
Okay, sorry. So no, okay, sorry. So this is given at from the minus L to plus L. So minus L to plus L. Okay, sorry, I have done this thing. So they have just used calculate this integration. But what was the wrong into this value?
Phi 1 state name.
Phi 1 is even function.
Then?
Sir, phi 1 corresponds to na pi square h cut square by 2m into 2l.
2l square, obviously. So this is not your phi 1 state, because your width is minus L to plus L. So what is your En? Your En is equal to n square pi square h cut square upon 2m 2l square. Are you getting my point? So this value is n square pi square h cut square upon 8m L square. And what is your E1? E1 is basically pi square h cut square upon 8m L square. And what is your E2? E2 is 4 pi square h cut square upon 8m L square. That is actually pi square h cut square upon 2m L square. Are you getting my point? So first thing is that you have to take this particular value as, what happened?
क्या हो गया?
स्क्रीन नहीं
कोई
दिख रही।
शेयर कर रहा है क्या स्क्रीन? शेखर,
What happened?
हेलो
हेलो शेखर।
सर आपका ना स्क्रीन चला गया।
नहीं, मेरा स्क्रीन तो चला गया, किसी दूसरे का कैसे आ गया?
हाँ शेखर,
किसी ने अपना स्क्रीन शेयर कर दिया सर।
अब आ रहा है क्या शेखर जी? You are viewing Shekhar screen. Hello, Shekhar.
हाँ सर वो कोशिश कर रहा है शायद।
ओके कोई बात नहीं, ओके हो गया होगा, दब जाता है, कोई बहुत बड़ी बात नहीं है, ठीक है।
जैसे लगता ही है।
yes sir, ठीक है।
ओके सही है यार। स्क्रीन रिकॉर्ड कर रहे थे क्या यार? तुम्हें वीडियो ऐसे ही दे रहा हूं, है ना शेखर? ओके डोंट डू दिस थिंग, है ना। You have all this access of this video and these all will be free into YouTube. Don't worry about this thing. You are just wasting your time. Okay. Anyway, so what is the wrong thing here? The wrong thing is that we have to take here what? Phi 2. Okay. And when you will take phi 2, this phi 2 is cos function or sine function?
Sine function.
Sine function. So basically we have to go for this integration minus L to L, and that is 2 upon 2L sine pi, and this will be sine 2 pi x upon 2L, and then we will put the value of psi, and psi is equal to x plus L, and sorry, L plus x minus L minus x dx. And now you need not to do this integration because this integration is what? Odd integration, है ना?
Yes sir.
अगर x को माइनस x करोगे तो ये वाला टर्म आ जाएगा, और इसको माइनस करोगे तो ये वाला टर्म आ जाएगा. So it is even integration and it is odd integration. So probability of getting this particular thing is equal to what? Zero. But what people done? They just go for the cos part, and once they will go for the cos part and they will take pi x by 2L, and they just do this integration, they will get some number, and that will also matching with the 4 option. Okay, so this is again one of the very interesting problem. So you have to be very much careful about your system. You have to think little bit how we can use this particular mathematics and how you can go for all this particular thing. Clear hai na? So this type of thing we have to take care when we are going for the examination. So let me go for one more question, and that was also a very beautiful question for your examination. And today I am deliberately taken the problem who is related to particle in box itself. Okay.
Yes sir.
Chalo.
सर इस टाइप का गलती मेरा बहुत होता है।
वो तो होगा ही ना, जब तुम बोलोगे कि क्वेश्चन ही गलत है तो होगा ही, है ना. First to be positive and a little bit sensible about the examiner. Are you getting my point?
Yes,
है ना,
sir.
सबसे ज्यादा इंपॉर्टेंट ये है. ठीक है. ओके. सो इस तरह की गलती नहीं होने के लिए मैं ये क्लास ले रहा हूं. आर यू गेटिंग माय पॉइंट?
Yes, sir.
ओके.
Yes.
तो ये सब चीज आप अपने दिमाग में रखोगे. नाउ this question was came into June 2014. So at that time there was some good question came in the exam, and again your particle is confined into, and the potential is given, Vx is equal to 0, x is between 0 to a and infinity otherwise. And they have just asked this question, they have just given that psi x is equal to a sine cube pi x by a, where x is between 0 to a and 0 otherwise. And 0 otherwise. So what they ask, they just ask what will be the average value of energy. What will be the average value of energy? So at that particular time, the level of examination was not so good. Suddenly the examination came into their real mode. Before that, it was little bit tricky question, just example type question, just getting the formula and just writing each and everything. So at this year, suddenly they have give this problem. What most of the people done in this problem? Most of the people, first they find the normalization constant by this formula. Now you can see the toughness of this thing. 0 to a must be equal to 1. Then you have this integration. Sine 6 pi x by a dx 0 to a. And after getting integration, they just go for this formula psi star h psi dx 0 to a, and h is nothing but minus h cut square del square psi upon del x square. So you will just go and differentiate it, and you have two function, and again you will go for differentiate it. It will totally mess, and then you have to go for integration. Are you getting my point?
Yes, sir.
Yes, sir.
So this is not a way to do the calculation. This is not a way to do calculation. Whenever this type of calculation will come, think that is that any another method to this problem or not? So yes, there is another method. So we know that sine cube formula, isn't it? We know this particular sine cube formula. So we have this particular thing. So whenever this type of problem will come, what you have to do? You have to just go for this type of writing. So sine 3a, you know what is sine 3a? That is 3 sine a minus 4 sine cube a. And now from here, we can easily write what will be sine cube a. Then sine cube a is nothing but 3 upon 4 sine a minus 1 upon 4 sine 3a. So this is nothing but the superposition of sine a and sine 3a. Now we can go into this particular thing. So what we can do? We can again write it in a superposition of our wave function, isn't it? So whenever this type problem came, just try to go into superposition of wave function. Just try to get this particular thing. So now that thing will be very easy now for you. So what you have? So you can easily write a sine cube pi x by a must be equal to a 3 upon 4 sine pi x upon a minus 1 upon 4 sine 3 pi x upon a. What do you have to do? You have to write this thing as a phi 1. You have to write this thing as a phi 3. So what do you have to do? You have to just go and multiply with root 2 upon a and root 2 upon a. Then only you will write it phi 1. Okay?
Yes, sir.
कई लोग तो है कि नॉर्मलाइजेशन को छोड़ देते हैं. Then your a will be very dangerous. Okay? So now, if we are taking 3 upon 4 and you have root under a upon 2, root under 2 upon a, that is sine pi x upon a, minus, again we have to do the same exercise, that is root under a upon 2, root under 2 upon a, and this value is again sine 3 pi x upon a. Now you can write this thing as phi 1 and this thing as phi 2, and you can get the value of a, isn't it? A will be something like this. Okay, you can get the value of a here. समझ में आ रहा है मैं जो कह रहा हूं?
Yes, sir.
है ना? So this is very important that you have to write the orthonormal. So if you are writing this thing, so if you are not using root 2 upon a, root 2 upon a, then it is not normalized. So you have to always write in an orthonormal term. So from here we can easily, and this is your psi x, this is your psi x, then you can easily write your mod a square, that is 9 upon 16 into a upon 2 plus 1 upon 16 into a upon 2 is equal to 1. So from here you can get the value of a. So a will be a very, so what will be value of a? So a will be root under 32 upon 10 a. Okay, 1 by a. So this will be value. You can just calculate it.
Yes,
है
sir.
ना? आ रहा है ये 9 plus 10
Yes, sir.
a. So that will be a. And now when you will put the value of a, then you have a probability, then you have your C1 and C2, and that C1 and C2 or C1 and C3, you can say C1 and C3 must be some number that should be independent of a. So yes, that should be have basically dimension of root under A such that this A and this A will be cancelled out. Are you getting my point?
Yes, sir.
So
Yes, sir.
when we will go for this, then we can finally write each and everything in a superposition of this particular thing. So that value is equal to 3 upon 4 root under 32 upon 20 phi 1 minus 1 upon 4 root under 32 upon 20 phi 3. Now you can easily find the average value of h, isn't it? This is normalized and this is your psi x0. If this is normalized, now you can easily find the average value of h. What will be average value of h? That is 9 by 16 into 32 by 20 into E naught plus 1 upon 16 into 32 upon 20 into 9 E naught. है ना? Yes. So this value you can easily get the final answer, and that value is equal to 9 by 10 pi square h cut square upon 2ma square. So this is your average value of h. So this is again a very wonderful problem. In the next exam, maybe they can ask what will be psi t after time t, isn't it?
Yes.
They can again ask this question that after which time that will be psi t is orthogonal to psi 0. Yes or no? Unless
sir.
until you will not able to write your psi in a basis of energy eigenstate, you cannot do anything with the time evolution. So always keep in mind that whenever the time evolution part will come there, or average value of energy or something like this. So first thing is that go and write in a basis of eigenstate of Hamiltonian. And you know the eigenstate, you have to just do little bit of calculation, something like this. The basic trigonometric formula, if you are just acquainted with all this thing, you can easily go for this. Okay, so these three are not only three problems. These three are important problems. Other problems are also good, but you can do it with yourself because there is not so much calculation is there. So in this three problem, we have wonderful calculation. You can say how you can see that how important is to read the question in a very nice way, in a very honest way. That second question we have done. You can see how you can use the formula and make the thing simplified once we have done the question number 1 and this particular question. Okay, so concept is very important, but most important thing is that how efficient you are in the calculation. If you want to do the quantum mechanical problem, then please do hard practice on your calculation. So I am again and again requesting to you, just try to go and solve the textbook problem, unsolved problem. Okay.
Yes, sir.
Sir, voice break हो रहा है, screen भी नहीं